Electric energy consumption is the form of energy consumption that uses electric energy. Energy is very important overview. Consumption of electric energy is measured in watt-hours. 1 watt-hour equals 3,600 joule equals 859.8 calorie. Electric and electronic devices consume electric energy to generate desired output. During operation, some part of the energy, depending on the electrical efficiency, is consumed in unintended output, such as waste heat. Electricity has been generated in power stations since 1882. The invention of the steam turbine in 1883 to drive the electric generator started a strong increase of world electricity consumption. In 2008, the world total of electricity production was 20,279 terawatt-hours. This number corresponds to an average rate of around 2.3 terawatts continuously during the year. The total energy needed to produce this power is roughly a factor 2 to 3 higher because a power plant's efficiency of generating electricity is roughly 30 to 50%. The generated power is thus in the order of 5 terawatts. This is approximately a third of the total energy consumption of 15 terawatts. In 2005, the primary energy used to generate electricity was 41.60 quadrillion BTU. The gross generation of electricity in that year was 14.50 quads. The difference, 27.10 quads, was conversion losses. Among all electricity, 4.84 quads was used in residential area, 4.32 quads used in commercial, 3.47 quads used in industrial and 0.03 quads used in transportation. 1 quad equals 1.055 exajoule. 16,816 terawatt-hours of electric energy was consumed by final users. The difference of 3,464 terawatt-hours was consumed in the processor generating power and lost in transmission to end users. A sensitivity analysis on an adaptive neurofuzzy network model for electric demand estimation shows that employment is the most critical factor influencing electrical consumption. The study used 6 parameters as input data: employment, GDP, dwelling, population, HDD and CDD, with electricity demand as output variable. World electricity consumption down. In 2009 at the world level, energy consumption was cut down by 1.5% during 2009. For the first time since World War II, except in Asia and Middle East, consumptions were reduced in all the world regions. In OECD countries, accounting for 53% of the total, electricity demand scaled down by more than 4.5% in both Europe and North America, while it shrank by above 7% in Japan. Electricity demand also dropped by more than 4.5% in CIS countries, driven by a large cut in Russian consumption. Conversely, in China and India, electricity consumption continued to rise at a strong pace to meet energy demand related to high economic growth. In Middle East, growth rate was softened but remained high, just below 4%. World electricity consumption. The table lists the top 37 electricity-consuming countries, which use 19,000 terawatt-hours, i.e., 90% of the consumption of all more than 190 countries. The total consumption and the energy sources to generate this electricity is given per country. The data of 2012. The last column contains the number of millions of inhabitants. Consumption per head. Total consumption divided by number of inhabitants gives a country's consumption per head. In Europe this is between 5 and 8 megawatt-hours. In Scandinavia, USA, Canada, Taiwan and South Korea it is much more, in developing countries much less. The world's average is 3 megawatt-hours. A very low consumption per head, as in Indonesia, means that many inhabitants are not connected to the electricity grid. and this the reason that the world's 7th and 8th most populous countries, Nigeria and Bangladesh, do not appear in the table. Electricity generation and GDP. Listed countries are top 20 populous countries in, or top 20 GDP countries, and Saudi Arabia as of CIA World Factbook 2009. 30 countries in this table represent 77% of world population, 84% of world GDP, 83% of world electricity generation. Productivity per electricity generation can be measured by dividing GDP amount by the electricity generated. World average was $3.50 production, kWh. Electricity generation include final consumption, in-process consumption, and losses. Electricity final consumption by categories. About 17% of total electricity production is consumed by in-processes, such as self-consumption of power plants, grid losses and storage losses. In 2008, total electricity generation accounted for 20,261 terawatt-hours, while 3,464 terawatt-hours were self-consumption and losses, and 16,816 terawatt-hours went to final consumption. In the consumption rate in industry, China is highest with 67.8%, South Korea is 51.0%, Germany 46.1%, Japan 31.5%. USA 24.0% in the commercial and public service. Japan is highest with 36.4%, USA 35.6%, China 5.4%. For domestic usage, Saudi Arabia is highest with 56.9%, USA 36.2%, Japan 29.8%, China 15.5%, Korea 13.8%. Definition: industry. Iron and steel, chemical and petrochemical, non-ferrous metals, non-metallic minerals, transport equipment, machinery, mining, food and tobacco, paper, pulp and print, wood and wood product, construction, textile and leather, non-specified, transport, domestic aviation, land transportation, rail, pipeline transport, domestic navigation, non-specified. Note: international marine and aviation bunkers are not included. Fishery. Some countries include fishing with agriculture or forestry. Electricity consumption of OECD member countries. Electric energy consumption per inhabitant by primary energy source in some countries and areas in 2008 is in the table. 1 megawatt-hour year equals 114 watt for the OECD, with 8,991 kilowatt-hours year person. 1.026 watt person. Electricity scenarios until 2040. In all scenarios, increasing efficiency will result in less electricity needed for a given demand of power and light, but demand will increase strongly on account of growing economy in developing countries and electrification of transport and heating. Combustion engines are replaced by electric drive, and for heating less gas and oil, but more electricity is used, if possible with heat pumps. As transport and heating become more climate-friendly, the environmental effect of energy consumption will be more determined by electricity. This is mainly supplied by burning fossil fuel, which disturbs the natural carbon cycle. The scenarios arrive at very different results for the environment. The International Energy Agency expects revision of subsidy for fossil fuel, which amounted to $550 billion in 2013, more than 4 times renewable energy subsidy. In this scenario, almost half of the increase in 2040 of electricity consumption is covered by more than 80% growth of renewable energy. Many new nuclear plants will be constructed, mainly to replace old ones. The nuclear part of electricity generation will not increase much, from 11 to 12%. The renewable part goes up much, from 21 to 33%. That is not enough. The IEA warns that in order to restrict global warming to second C, the carbon dioxide emission must not exceed 1,000 gigaton from 2014. This limit is reached in 2040 and emission will not drop to zero then. The World Energy Council sees world electricity consumption increasing to more than 40,000 terawatt-hours in 2040. The fossil part of generation depends on energy policy. It can stay around 70% in the so-called jazz scenario where countries rather independently improvise, but it can also decrease to around 40% in the symphony scenario if countries work orchestrated for more climate-friendly policy. Carbon dioxide emission, 32 GT, in 2012, will increase to 46 GT, in jazz but decrease to 26 GT, in symphony. Accordingly, until 2040 the renewable part of generation will stay at about 20% in jazz but increase to about 45% in symphony.